Hello friends, I am Dr. Ashish Kadam from the Pune, India. Now today we are in the fourth part of the video series on the button mushroom farming project. In last three videos, we have discussed in details about the health benefits of the mushroom, various products which we can make from the mushroom, and also we have discussed in detail about the farming technologies. We discuss about the how to make the good compost and what are the different processes which we need to take or need to do in the cropping area. Now today we are into the fourth part, and in the fourth part you will discuss about the various guidelines, various design considerations which we need to consider when you are going for the planning the button mushroom project. Let us start with the fourth video. Now the first slide of this video series will tell you about the production process, will tell you about the process flow in the mushroom production process. Now you will see that these are the two different figures uh, I have taken in front of you. On the left side you will see the process flow, and on the right side you will see the production process. Now let us look at this flow chart. Now here the material is coming. Now so far you are very much familiar with the button mushroom processes. We have understood in a detail from video 1 to video 3 about these processes in detail. So we are just summarizing those processes. So if you align your entire farm, your entire production facility in line with these process flow, certainly you will have the better efficiency, you will have a better control on the overall production process. Let us understand these processes in a detail. Now let us start with the first part. So where we are receiving the casing material. So we require the casing material. Now again we require the compost. Either the compost will come outside the from third party source, or you can make your own compost. We have discussed in detail about this in video 2. And also you require some other auxiliary materials, like you requires gloves, you requires aprons, you require knives, you requires cleaning material, and so many other things when you are running the professional plant. So these are the three places where you are receiving the material. Now for all these three materials we need to have the storages, we need to demarcate the storages. So all this material will first go into the storage areas. From the storage areas, then they will go into the place where you are going to utilize them. Now for example, the compost, if you are procuring this compost from the third party source, then you did not require to store the compost on your farm. You can directly use this compost for filling the beds or the bags in your growing rooms. One more interesting thing you can do, you can directly bring the filled in bags or spawn filled bags, and you can directly press into your growing room. So for the compost here we do not require a storage area or the storage yard. So this compost will go into the growing room, and where the germination and incubation of the spawn or the spores or the seeds of the mushroom will start in provided right environment. Once this process starts, or you get the good growth or good spread of the mycelium, once you start seeing the milky whitish color in the compost, then you start the casing. So the casing will then come from the storage yard. Now from the storage yard it will go into the pasteurization chamber. After the pasteurization chamber, then it will come into the growing room area. So we need to provide this process. After this process, then the pre-fructing or the we call it is the pinning phase starts. So here the pinning phase will start, where we are basically provide the air conditioned environment, and from after the pinning then you will get the button mushrooms. Once you get the right size of the button mushroom, then the harvesting will start, and after the harvesting of maybe 2 or 3 flushes, then we will start emptying the compost. Then we'll pasteurize this, we'll disinfect the entire growing area, and this compost then we have to dispose at right safe place. So this is the basically the entire process which we generally follow. Now if you see this process, and now you look at the processes which are given on the right side of this figure, then we require dry storage area. So when you are having this casing material, compost, other auxiliary materials, consumables you have, then you require the storage area for them. From these storage areas, they will go into the pre-wetting area. For example, you are making your own compost, for example, then you require so many things. You require the bagasse, you require the fertilizers, you require the gypsum, you require the chicken manure or horse manure. So these materials to be stored in the dry area. So there has to be a dry storage area. So from the dry storage area, the material will go into the pre-wetting area. So this pre-wetting area or these ponds have to be very much closer to the dry storage area. Otherwise, you will have a lot of cost. You will require a lot of even time for the handling of the material from the dry storage area to the pre-wetting area. So we have seen that for 1 square meter of area, or to fill 10 bags, you will require 100 kg of the compost. So if you are having 1000 bags growing rooms, or if you have 3000 bags uh, uh, growing room, then you will require around 40 metric ton size of the compost. So you have to shift, you have to move very huge quantity of the raw material to make the compost. So that is the reason the dry storage yard has to be very much closer to the pre-wetting area or the pond where we will wet this, where we will soak this material. After the pond, there has to be a mixing platform. There has to be mixing platform which is provided with a shade. After this, the material will go into the bunkers. From the bunker, then it will go into the pasteurization tunnel, and from the pasteurization tunnel, then it will go to the spawn mixing area. Sometimes you can directly ship this material. If you have the bed method of farming, then you can directly ship this compost directly into the growing room. This is the technology now people are adopting. If you are going for the mass production, or still if you want to follow the old methods or traditional methods, then you can use this spawn mixing area where you can mix the pasteurized cold compost with the spawn spores or spawn inoculated grains, and this is the area. After this, the bags will get shifted into the growing area or the cropping area. After the cropping area, then you will get the flush of the button mushroom, and this button mushroom will get shifted to the packing and the processing area. So this is the flow we have. Similarly, for the casing material also, you will require the casing storage, then you will require the wetting area or the soaking area, then we require the pasteurization, and after the pasteurization, this casing material will go into the growing area. So this is the production flow. So your production flow has to go in line with the process flow. This is very important. So there should not be any crisscross of the functions. Or suppose, for example, if your dry storage area, if it's close to the growing rooms, then there is a possibility of even cross contamination. Okay. Or for example, if you are storing your spent compost, if it is very much closer to the pre-wetting area, then there is a possibility of the even cross contamination of the diseases of the old compost with the new compost or new bagasse or new ingredients which you are using for the making the new compost. So that is the reason there has to be a certain sequence which we have to follow when you are designing, when you are planning your entire mushroom production facility. Otherwise you will have a lot of handling, otherwise you will have a lot of movement of the people. Another important factor we have to consider here when you are designing is that you have to separate unclean area and the clean area. We have discussed in video 2 and video 3 that the processes which we do after the pasteurization of the compost have to be completed, how to be performed, how to be conducted in very clean sterile environment. So this is the tunnel. So after the tunnel, all of these processes have to be completed in very clean environment. So before this, your area can be unhygienic. Unhygienic means it should be hygienic, but you do not require to take that level of the care what you are going to take for the growing room, or for the packing area, or for the processing area, or for the storage of the casing material, or casing pasteurization. So kind of attention you need, or kind of cleanliness you want in these areas, you will not require to be maintained to that stringent level for the compost preparation. That is what the point I wanted to make here. So accordingly you need to segregate these areas. Okay, so that is the important point. Please remember when you are planning the your mushroom project. Now let us understand how to calculate the cultivation area or the cropping area. Now let us understand we are planning for 1000 kg of production for a day, 1000 kg of the button mushroom production I am saying here. So for a year you require 365 metric ton of the production, because in a year we have a 365 days. So 365 days into 1000 kg, you will get the 365 metric ton of the button mushroom production. So this is the total production, or this is the total volume of the production you will get in a year. But for planning we have to always do for a day. That is very important thing. So if you are planning for a 1000 kg or for a day, then you will require the area at this proportion. So if you see this number, so in India our yield per square meter is 18 to 20 kg. But if you go into the Europe, if you go into the Canada, or if you go into the China, then people are getting the yield at this number 23 to 27 kg per square meter. In fact, it is interesting to know that few farms even have reached to the 35 kg of button mushroom per square meter of area. So this is what the yield the people have achieved. So it is possible certainly to achieve this yield in India also, if we take right care, if you have right design measures, if you have right planning, if you have the right training, if you have right standard operating procedures for each and every activity, if you have the checklist for each and every activity. So if you are putting that level of effort, certainly it is not a magic to achieve this number. You remember, and this is very important factor we need to remember. So it is something not that challenging, but only we have to inculcate those habits. We have to take those cares when you are designing your plant. Now coming to again back to this. So in India we generally do the planning for area considering 18 to 20 kg of yield for a 1 square meter of the cropping area. So we know this factor that one cycle of the button mushroom you require around 57 to 60 days of the time. That is, in a year we can have maximum 6 cycles. You can have a maximum 6 cycles. So total area required to have this much of the production, to have this 1000 kg of a production at this yield, you will require 3380 square meter. So this is just simple arithmetic, because you are planning for 1000 kg. So you will require this much of the square meter of the bed area for the making the compost. So width of the shell we will assume around 1.3 meter to 1.4 meter in the growing area. You have understood this, because in the last video we have discussed, because we are growing the mushrooms on the beds, or we are growing the mushrooms on the bags, and these bags are kept in the galvanized shelves or in the aluminum shelves. So we have to now design the shelf area required, how many shelves you require to accommodate those number of the bags or to accommodate that square meter of the bed area. So width of the shell will assume 1.3 to 1.4 meter. Now this is the width which will provide you the right access to the each and every button in on the bed. If you provide more than this width, then it will not be accessible for a picker to reach to that particular button mushroom in the corner. So that is the reason you need to provide a width not more than 1.4 meter. Now number of beds per shelf has to be maximum 6. Now we have seen when we are visiting the farms, we have seen that people have even 7, 8, even in few plants you will be surprised to know that people have even 9 and 10 shelves, because they have impression that more shelf they will have the more production, or they can get the more production in lesser cost. Okay, so we need to leave this point here, because that is not the right way to do this way. If you want, or if you are targeting the right yield of 23 to 27 or even more than that, then you need to have a proper planning. There has to be a proper air circulation. So we have discussed those points in the video number 2 and video number 3. So we will again assume the length of the shell, that is a 15 meter. So length of the shell is a 15 meter. Okay, now in the few plants people are even going for 25 meter, 30 meter, but then you have a challenge with the circulation of the air. So if you are having the right design in the place, then you can go for that length of the room. Okay, but you need to do a lot of calculations. You need to understand what are the air pressure drops are going to take place, what is going to be a draft velocity of the air, what will be the pressure drop air in the duct, what should be the velocity of the air in the duct. So all those calculations you need to place, then only you can go for the even higher lengths. But from my experience, that 15 meter length of the shelf is manageable and which will give the very right quality of the production. So we are considering 15 meter length of the shelf. So if you consider 15 meter length and 1.4 meter as the width, then on each shelf, on each bed of the shelf, or each compartment I would say of the shelf, you will get 21 square meter of area. So now we are targeting a production of 1000 kg. We are targeting a production of 1000 kg. Okay, so to get that 1000 kg of the production, we will require 27 shelves, because you require total 3380 square meter of the area. Okay, so how many shelves you will get, that you can work out from this. It is going to be a 27 shelves. So maximum shelves you can keep in a room are 4. Now you can see this picture. So this is a room. So this is the room, and there we have put the 4 number of the shelves, and now you can see that we have kept the right spaces around each shelf for the movement of the air. But again here we have to understand the position of your ducts which are supplying the air to these shelves. If your positions are not right of the ducts, then even though you have the right spacing across each and every shelf, you may not get the right air flow, you may not get the right air velocity for each and every button mushroom plant on the bed. And we have understood that we have to develop the microclimate. I have seen, we have discussed in very detail in last video of number 3 that microclimate is very important, and that microclimate has to be uniform across all shelves, across entire room. If there is no proper air distribution, or if there is no uniform air velocity, or if there is no uniform CO2 level or oxygen level, then you will get uneven production. So in some areas you will get bigger size buttons, in some areas you will have smaller size buttons, in some areas you will see the buttons are growing in the casing material, below the casing material, and they are getting dirty because they are growing in the casing, they are growing in the muds. So you will not have the uniform quality, you will not get the right quality of the flush. So that is the reason we need to put all the calculations in the place. Okay, so though it looks very simple that you can put the ducts, you can have the AHU, you can have this planning, but actually we need to do the calculations. We need to understand what velocities you require at each shelf level. In the Europe, in the foreign countries, in the Canada, people are measuring the air velocity at level of the button mushroom, at the height of the button mushroom, on the entire bed of the farm. That is how they are planning, that is how they are taking care, and that is the reason they have reached to this number of 35 kg of production per square meter. So planning, design, engineering, these are very important aspect of your process of the this project. So we will require 27 shelves to get 365 metric ton of the production in a year. So total shelves you will require are 27. So total shelves per room you can put maximum 4. Now this is not a number. You can even put more than that. In again I'm going and saying, in the foreign countries people are even keeping 6 shelves, 7 shelves, even they are gone to length 25-meter, 30-meter, but they are doing it on the basis of right engineering of the air handling unit, ducting system, air distribution system, and that is how they are taking care of those lengths, those many number of shelves in the room. So if you are doing that, certainly it is a possible to have the more cropping area per room. So total number of rooms you will require are the 7. Now one point here you need to understand, that we are requiring these 7 rooms, but are you going to fill the 7 rooms on a single day? Are you going to start spawning this entire cropping area on a single day? Are you going to fill the bags required for the 7 rooms on a single day? It may not be possible, it may not be practically possible, or it may be inhuman act. So that is the reason we do this process in a certain sequence. Okay, so first we'll do the filling for the room number 1. So room number 1 will get first commissioned. After the room number 1 we will go to the room number 2. We will keep the compost ready for filling in the room number 2, and this is how you have to go for the 7 numbers. So in a certain period of time your all 7 rooms will get commissioned, your all 7 rooms will get filled with the compost. So this sequence we need to understand, otherwise your cost of the infrastructure required to fill at one time all this room will go exponentially. So to reduce that burden on your infrastructure, because you will require bigger area to make the compost, you will require those many number of the bunkers and pasteurization tunnel, you will require those number of people to handle those number of bags for the entire farm. So it is not practically possible to fill all the 7 rooms on a single day. But certainly if you are going for a high-tech plant, you are going to take help of the machinery to fill up the compost in the rooms, then certainly you can reduce this time, and that we have discussed in very much detail in my last video. So you need to go and see that video. So coming to the next part, that is planning the compost quantity. Now we have seen in the last video that this is how we have to calculate the number of rooms required, number of shelves required to have 1000 kg of the production per day. Okay, so again I am repeating the point that you are not going to get the 1000 kg of the production on a first day. You will get the 1000 kg of the production as your all 7 rooms get commissioned. All 7 rooms get commissioned. Okay, so you need to reduce that gap. You can reduce that gap to fill the 7 rooms. Instead of taking 1 month, you can do this entire process maybe in 15 days of time, but it is not possible to complete this process in on a single day. So planning the compost quantity. Now we have seen that for each square meter of area we require to put 100 kg to 110 kg of the compost. Now again, few farms in Canada, few farms in the Ukraine, people have gone to 80 kg of the compost for a 1 square meter of area. So now even they have planned and they have reduced the compost quantity by almost 20%, and the production they have increased by 20 to 25%. So both ways they have acted and they have got the better efficiency, because if you reduce the quantity of the compost, naturally your cost of the material, your cost required to have that extra 20 kg of the compost will go down, and naturally your margins will increase. So this is how you can do it, but it may not be possible to do it on the first day of your project. You can reach to 80 kg of compost per square meter, maybe down the time as you grow in through your experiences, as you do a lot of experimentations and you do your own recipe to make the or to grow the button mushroom. Okay, so we will calculate the compost requirement considering this factor of 100 to 110 kg per square meters area. So now we have seen in the last slide that we are going to have 3380 square meter of area. So to fill up this much of area, how much quantity of the compost you will require? So it is a just simple multiplication. So if you do this multiplication, we will get the total quantity of the compost you will require for one room. So you will require for for all the 7 rooms for one cycle. So you will require around 371 metric ton of the compost to fill all the 7 rooms. So this is the total quantity of the compost we will require for a year. So you will require 2230 metric ton of the compost. That is, again I am going back and calculating how much compost is going to be there on each bed of the shelves. So we have seen there are total 6 beds are there on each shelf. So we will have 2.1 metric ton of the compost on each bed. So if you multiply by this into 6, you will get around 6.6 metric ton of material on each compost. So you need to design those shelves to take that heavy load of the compost. Plus you will have the load of bags, you will have the load of the people who are working, then you will have the load of water which you are spraying, you have the load of casing material which you are spraying on this. So this is how you have to design the shelf for bearing the weight of compost. So this is the total quantity of the compost required to fill all the 4 shelves in one room. So you will require around 50 metric ton of the compost for each room, for each cycle. So considering this quantity of the compost, now we have to go back and we have to design the pasteurization tunnel, we have to design the bunkers, and we have to design the platforms, ponds, etc. to make the compost required to fill one room. So this is how we do the planning for the compost. This is how we do the planning for the cropping area. Now let us understand how much time is required to complete this entire indoor and outdoor processes. So we have seen that compost making is we are considering as an outdoor process, but rest of the processes from the spawn area or spawn filling onwards are completed in the clean areas. So phase 1 composting, which we do on the platforms, we require around 5 to 7 days of the time. Then for the bunker, the material comes in the bunker, it spends around 5 days of time in the bunker for the maturization of the compost. After that it spent another 2 days for the pasteurization in the tunnel. Then we have another 5 days of period for the cooling off of this hot compost, because this compost is pasteurized, it is at temperature 65 to 70 degrees centigrade. So you cannot ship this directly material at this temperature into the spawn mixing area. We need to cool down the temperature of that compost, so we require to spend certain time. So this entire outdoor process or this compost formation process requires around 18 to 20 days of the time, and this is independent process. This is an independent process. So we need to perform this process outside the growing area. So you have to keep this material always ready, when you are going to start the growing area, when you are going to start the cropping area. After that we take another 1 day for mixing the spawn with the compost and or the backfilling. Of course here we are assuming that you are using the machinery, because if you are doing this process for with the human labor, if you are doing this process manually, then it will not be possible to complete this process in a 1 day, because you have to fill around 50-54 metric ton of material if you are planning for the 7 rooms for 1000 kg. So handling that 50 metric ton, it will not be human task, you require machinery. So that is how we are considering the time required, considering you have a certain infrastructure. After that, for the vegetative growth, that is to get the mycelium, we require around 12 to 15 days of the time. Then pinning to first flush, we require around 18 to 20 days, and then you get the 4 to 5 flushes, which will require around 20 to 20 days. So you will require around 50 to 56 days. As you mature your process, as you get the experience in this entire handling of all the processes, once you start understanding in detail, once you get the hands-on experience in compost quality, then the casing quality and overall uh, possession you get on the entire infrastructure, people and handling, then you may even reduce this entire time, and then you can have, I'm not saying it is a possible, but you may have another 1 cycle of production. So instead of 6, even you can go for the 7 cycle, but this is will come or after the hard planning. So after that we require around 1 day for emptying the compost. Again I'm saying, if you are using the human labor, then it is not possible to empty the room, you will require certain infrastructure for that. Then washing the rooms 1 day, and for sterilization, pasteurization, we will require 1 day, and after that again the rooms will be ready for the second crop or for the next crops. So total we have seen we have 50 to 56 days, so we let us assume 60 to 65 days. Again I'm taking 10 days more in this entire calculations to be more practical. So you will get around 60 to 65 days, and you can have total 6 cycles in 1 year. But if you consider 50, if you are going minute to minute planning, if you are going hour to hour planning, if your material, if your compost ready as soon as you are about to start the next crop. So if you have the just in time kind of a planning which is adopted, this is a management philosophy adopted in the Japan. So there they don't keep the inventory, so every material required comes just 1 minute or just half a minute before it requires in the production. That is what the just in time concept. So if you adopt just in time concept, if you bring that level of professionalism, then you can divide 365 by 50 and you can have 7 cycles. That is what I was telling. But this is very hard to do when you are starting the new plant. But down the line, if once you have 3 or 4 cycles, then you can start tweaking the time, then you can start crunching the time, and you can adopt, you can have 7 cycle. So if you have 7 cycle means you will get through the same investment, you will get the 7th cycle, means you will get more profit for your total investment, you will get more revenue for your investment, and that is how you can make it burden free as early as possible. But this requires planning. I'm again repeating the same thing. So unless you have the planning in place, these things are not possible to do. So these are the things, these are the bullet points we need to remember when you are planning. So what are those bullet points? I'm just reading those points. Avoid unnecessary movement for the labor and staff so that we can increase their work efficiency. So if you are planning If you are planning even the small roads, even if you are planning the small movement of the laborers and staff in your entire farm, then naturally they will give more output. Otherwise, we have seen that people are moving from casing area to compost area, then they are going to laboratory, and they are spending a lot of time in just walking. So if you are having that kind of a planning, then naturally the people will more spend more time outside your farm. They will not have more time available to do the effective work in your farm. So that is why the movement have to be planned, movement have to be predicted, mutual the movement of the people have to be forecasted, and we have to address those movements when you are designing the plant. So we need to prepare the architectural layout of the plant, which will address, which will discuss, which will study the movement of the material, movement of the people in the plant. So people, we have seen people are spending huge money. People are spending money in crores to set up the plants, but they are not taking care of these small aspects. So naturally your return on investment period goes high because your inefficiencies are increasing in the plant operation. So second point, keep separate team of laborers for compost making to pasteurization process, spawn mixing, growing rooms and laboratory, packing and processing area. So what that this is what we are proposing, that you should have the separate teams. If they have the work for every day, if your farm is small, if your farm is small, then we need to have the processes, we need to have the checks so that they will not do the contamination. Otherwise, if you are using the same team for the spawn mixing, for the compost making and for the packing, then there is a possibility of the cross contamination, just like what you are seeing in the corona disease, which is spreading like anything across the globe. It is kind of a cross contamination. So we have to avoid that cross contamination, and for that we need to have regular hygiene, regular health checkup, regular cleaning in the place. We need to provide regular training to the people. We need to make them educate, we need to make them understand that why cleaning is important, why cleanliness is important, why personal hygiene is important in these kind of operations. So you have to take a call. If your farm is small, you can have one team for doing all operations, but when people are moving from one area to another area, they need to clean themselves, they need to be disease free. If they are carrier of the diseases, then you will have a lot of problems. You will not see the problem, but you will see the impact in terms of diseases in your crop, in terms of lower production, in terms of lower quality, in terms of lower whiteness, lower shining, rough or pitted surfaces on the mushroom cap, and of course then your buyers will not be happy with your product quality. So the main purpose you are doing is for the better quality, better price for your product. So if you are not taking care of these things, then your objective of having this kind of investment, having this kind of a project will get challenged. Third point, reliable source of clean water and electricity. These are very important things, because when you are going for high-tech mushroom plantation, then we have to maintain certain environment. You have to maintain certain temperature, air circulation, humidity, CO2 level. And for operation of this, you requires 24/7 electricity. So there has to be either generator, or there has to be a right reliable source of the supply of electricity from the common grid. And another important point is here the clean water. The water which you are using for the compost making, or the water which you are spraying on the beds during the vegetative growth, has to be very clean quality water. If you are not using the pure water for these processes, then contamination may happen through the water, and this point we need to appreciate, we need to respect these points. So we need to have the reliable clean source of water and electricity. Another point 4, there has to be a separate storage yard for raw materials required for the entire plants. For example, you require wooden straw, we require uh, wheat straw, bagasse, fertilizer, casing material. We require lot of laboratory consumable materials, aprons, clothes, bags. So many things we require in the entire operation of the project. So we should have a separate dedicated areas for their storages, and those areas should be free of contamination. Those areas should be free of diseases. Those areas should be free of dust, mud, dirt, etc., or even rainwater. So we have to take care in right spirit when you are planning the plant for the storage of these areas. So separate yard for storing the spent compost. This is very important, and which is generally missing when you are planning it. So we forgot generally, or we forget generally, that we are going to get the lot of compost after the every cycle of the crop. And then questions comes, once we come to the point of removing the compost, then people starts thinking where to keep this compost, where to transport this compost, and generally they end up storing this compost very much close to the storage areas, or very much close to the this entire farm area. And then you have again problems, because this spent compost may have certain diseases of the last crop. So if you are keeping this spent compost, waste compost, which is a contaminated compost, which is uh, colonized with the bacteria or the viruses, then again you will have the spread of the new diseases in your next crop. So we have to take lot of care for even storage of the waste compost. So this area has to be as much as far away from the farm area. That is what we are always recommending. Then sixth point is the separate isolated labor quarters. So labor should be staying away from the farm. Many of the times we have a consideration that if the laborers are staying in the same campus, naturally they will be available 24 hours for the plant, 24 hours for the operation of the farm. But that is the not right way of addressing or so solving the issue. Okay, there has to be a certain separation between the labor quarters and the farm areas. So we can have a right design. You can change the directions of their gates of their quarters. You can provide a separate road for them, or you can have the partitions of the some good material in between the farm and those labor areas, so that again the cross contamination will not happen. And another important aspect is that many of the times, if you are going for the export oriented project, and again saying, if your desire is to export, if you are looking for the overseas market like China or Russia or the cold countries or Middle East countries, then people are, those buyers are very much cautious about the cleanliness of your project. They are very much cautious about the planning of your project or your operation. So if the laborers are staying in your campus, certainly it will look little ugly, because those laborers will not be staying like they will be doing their all household activities outside their quarters, like washing the clothes, washing the utensils, and so many other things. Even they will take the baths in open areas. And if those buyers see those kind of activities very much close to your farm, then they will get disappointed. So we have to look very professional, we have to look very clean, we have to appear very hygienic. Then we have to do all those points. We have to take care of all of these points. Then seventh is keep surrounding clean. Always we have to have the right facility management practices in the entire campus. Eighth point is the separate isolated pit for the drainage or effluent treatment plant. This is one of the important point always get missed when we are designing a new plant. So people forget that they will have the sewage, they will have the generation of the wastewater. So once they starts getting the wastewater, then they starts thinking how to get rid of those problems. But if you have the right planning, if you are taking care of them, then certainly it is not a challenge, it is not a problem down the time when you are operating the farm. So these are the important points we need to understand, we need to appreciate, we need to address when you are doing the architectural layout, architectural designing, or the engineering of this entire project. Now coming to the next point, that is a dry storage for the bagasse and paddy. So we'll see each and every process again, which we have discussed in detail in the video 2 and video 3. So what are the aspects, design considerations are required to be considered for each and every step, each and every process of your project. So we should have the plain and dry flooring. So flooring for the storage area has to be plain, it has to be rigid, it has to be hard, it has to be dry, it has to be free from rainwater, it has to be free from the even winds, because winds brings lot of contamination, winds brings lot of diseases, wind brings lot of even pollen particles of different flowers, and all those flowers then will starts getting germinating in your compost once they starts getting the right environment. So, and of course we are providing that environment, so we need to have that point in the storage when you are planning the dry storage areas. So proper water drainage arrangement is very important. Then preferably there has to be a shade and cover, but it is optional, because sometimes we have also to look at the budget or the investment component, and we have to be very much practical, or we have to trade off between the investment requirement and the necessity of the particular requirement. So we have to, but this is some, I would say not necessary, but it is nice to do kind of a thing. So preferably there should be shade and cover. Fourth is the compound and wire fencing is essential. There should not be electrical wires running around these areas, because this material is very much susceptible to the fire. So if there is a if the laborers are smoking, or if there is electrical wires are going around, or if there is electrical transformer around, or if for example by mistakes people are in the winter, for example, they have the fires, then there is a possibility of the fire to these areas. So we have to take care of this, and incidences have happened. So point 5 has not come just for my from my wish list, but it has come from the experiences. So we have seen the fires. And sixth is the emergency water supply. So though we are taking care of this, there may be possibility of the fire. There is a possibility of fire. Sometimes fire comes even from the lightning also in the rainy season. So we have to take care of that. So if you have the right firefighting system, then we can immediately extinguish the fire, and we can save from our investment, save our materials. Seventh is the weighing scale for weighing the truckload. So we have seen that we require 50-55 metric ton of the material for each load depending on your cropping area. So we should have the weighing scale machine very much close to your farm. Otherwise, if you are depending on the third party or the seller's weighing scale, then you may get, because those weighing scales may not be calibrated, or they may have tweak for showing higher numbers on the weighing scales, then you will end up in getting the lesser quantity of the material, and then you will have the impact on the lesser quantity of the compost in your cropping area. And another point is that whatever the material you are shifting or you are using for the compost has to be accurately weighted on the scales. So for example, you are making 50 metric tons. So to make 50 metric ton of the compost, how much kg of the bagasse I will require, or how much kg of wheat straw I need, how much kg of gypsum I need, manure I need, chicken manure or horse manure, what you are using. So if you take the measurements of them, then you will have the right proportion, and then you will get the right quantity. Otherwise you may end up even adding more gypsum or more chicken manure, and that is also not good, because your cost of your production will increase. So if you are going for a very big size of the plant, I would always recommend to have the your own weighing scale on your farm and very much close to the dry storage area. Then next process after the this is the pre-wetting pond for bagasse and paddy, etc. So whatever the dry material you are requiring for making the compost, it has to be soaked, that we have seen in the video number 2. So what are the considerations we need to take? So depth of the pond should be 2 to 2.5 meter. There should be proper slope should be provided on all side of that particular depressed area of the pond. And point number 2 is the size of the pond should be sufficient to accommodate the entire load of the bagasse required to make one batch of the compost. Then slab should be of the right grade. There has to be a right designing in the place, and because we are using again heavy earth moving machinery like hydraulic turners or maybe JCB or something like that, so it is continuously moving 24/7, and for the life of the project, maybe 10 years or maybe 15 years, if you are designing your entire project, then it is running for that, so it should not get damaged. We have seen many of the times that people are not doing the right foundation, right pitching, they are not putting the right filling material to make the foundation for the RCC slab, and after 1 or 2 years of the time they will see the huge cracks, and then they are spending a lot of money on the maintenance of that. And once you start getting the cracks, then again there is a possibility of the earth material like dirt, etc., from the foundation, maybe sand and etc., is mixing into your compost and degrading the quality of the compost. So we have to take right care when you are designing the RCC slab, or we are constructing the RCC slab. And in the video number 2 we have seen what should be the quality of the RCC slab. We have seen the photos of that. So fourth number is the life of the pond should be minimum 10 years. So that level of quality we need to build up in the pond. Water drainage arrangement for the cleaning of the pond. So after soaking of the wet bagasse, the whatever the water is there, it has to be drained out, it has to be removed from the pond, the pond has to be cleaned. Otherwise there is a possibility of the formation of the colonies of the bacteria and pathogens, so we have to avoid that. So there has to be a system in place to clean the ponds frequently. So if you have the right drainage arrangement, if you are providing the right gutters, right slopes, right sizes of the arrangement for even cleaning the gutters, because you are playing with the all the agricultural material, so they may jam all the water flow areas. So we need to have the even access points available in your gutters, etc., so that you can frequently clean those and you can allow the free flow of the water to take place in those areas. And sixth is the lighting arrangement. So overall entire plant has to be illuminated, it has to be provided lighting access, so that you can work down the time, you can work all 24 hours of the day, and you can increase the efficiency of your entire project, so that even in the night also you can do the turning, you can do the shifting of the all the agricultural waste from one area to the another area, and this is how you can build up the efficiency of your investment. So always you have to bring that level of the professionalism, planning, uh, arrangement of the or the planning of the shifts of the labors and etc. And seventh is the there has to be a roof or shade, which is highly recommended, because sometimes we have almost 3 or 4 months of the year we have the rainy season, so we have to take care of that. Then another point, another phase is the mixing platform. So after the soaking the bagasse or maybe the paddy and etc., we have to mix this material with the different fertilizers and chicken manure. So there has to be a mixing platform and turning platform, you can say. So what are the considerations we have to take? Size of the platform shall be sufficient for movement of hydraulic turners, loaders and compost. Shade of minimum 18 feet height should be provided, and it basically we are providing this shade for protection from the sunlight, rain and dust. So shade is very much recommended. Shade, I would say, is very much essential aspect of this entire process. Third is the RCC slab shall be designed for movement of heavy earth moving machinery. RCC slab should not get the cracks after a certain period of time, so it should be designed for the through the right engineering. So even I would recommend that taking the core samples of your land, of your earth, so that we can see what is the quality of the strata, how is the core samples, and accordingly we can even do the designing for the this RCC slab, so that you will not have the surprised cracks, crevices, holes in the slab. And fourth is the life of the platform shall be minimum 10 years, because you are doing such a huge investment. It should sustain, it should prolong for 10 years. In fact, it should go very much close to the minimum 15 years. That is my expectations, but at least we should plan for the 10 years. Then fifth is there should be available water supply tappings to sprinkle water frequently for the when you are turning the compost, because lot of heat is generating in this entire process that we have seen. Then six, the proper efficient water drainage arrangement for the cleaning. Seventh is the lighting arrangement for work, so that people can work across the 24 hours and they will be available for us, and we can then speed up the entire process. Next is the bunker. So once you make the compost on the turning platforms, then we shift for further maturization of the compost in the bunkers. In the bunkers we supply the air from the bottom, that we have seen in the video number 2, and how to design the bunker, etc., we have seen. But these are some of the important aspect or considerations which we are again discussing here. The size of the platform shall be sufficient for movement of loaders and compost. We have seen in few of the plant that the platforms have collapsed because of the movement of the heavy machinery, heavy earth moving machinery. So we have to design the platform accordingly. Then shade of the minimum 8 feet or 20 feet should be provided for the protection from the sunlight, rain, dust, pollen, etc. RCC slab shall be designed for the movement of these heavy moving machinery. Life of the platform, again I am repeating, it is a 10 years, but I am expecting it should be close to 15 years. There should be water supply, tapping to sprinkle water if required, or for the cleaning of the bunker areas. Then there is a possibility of the choking of the air holes. We are providing perforated holes in the slab, so sometimes those holes or the small crevices which we are providing, or small you know uh, spaces we are providing in the slab, they gets close because of the compost, so we need to open them, otherwise the air, proper efficient air circulation will not happen. So we have to use the water source for the cleaning, so there has to be a tapping available. Then sixth is the water drainage arrangement. Again, you have seen here that when you are cleaning the bunker areas, the water is getting accumulated below the slab of the bunker, and it becomes like then like a drainage pit, and then you have the colony of the bacteria, and even water starts petrifying, and then you even get very bad smell, and it damages the entire environment of the farm. So there has to be a proper drainage arrangement provided, so that After the cleaning, the water will flow easily out of the bunkers. 7 is the lighting arrangement for work during the night time. And bunker shall be size for maximum 25 to 30 metric ton compost. So bunker should not be size for bigger than this. If you are sizing for bigger than this quantity, then there is a possibility of inefficient circulation of air. So compost should be, and another aspect is here, the compost should be poured from top using conveyor belt so that the pile will not get compacted and will remain loose and porous for air circulation. So this is very important point. But we have seen that in India people are using the loaders, or the people are using the earth moving machinery or the JCB tractor for filling the bunkers. So when these earth moving machineries are going inside, they are basically compacting it. So if you are compacting the compost, then density of the compost will increase, and the holes or the porousness or the gaps in the compost material will get removed, they will get plugged. And then if you are supplying the air, even you are supplying at very high static, you are using very big fans and blowers, it will not help to have the proper air circulation. Again, I am saying it here that even 1 gram of compost should get oxygen, should get air. That is what the planning should be. So you have to design in a such a way that every gram of the compost of this 25 to 30 metric ton of the material which you are shifting into the bunker area should get sufficient air flow. So that level of micro planning has to be there. So that is the reason it should be very loose material. It should be like sponge. The compost material should be like a sponge, so that air will easily flow across the depth of the compost, and then you will have the very efficient oxygen circulation in the compost. Then you will get the uniform quality of the compost, and then you will have better nutrients and minerals. The compost will get properly maturized. Every gram of the compost will be same like 25 or 30 metric ton. You can take any sample and it will be of like same other sample. So that kind of confidence we need to build into the processes. Otherwise you will your crop will not get the same quality or uniform quality of the compost, and then you will have uneven yield in the bed. So pasteurization tunnel. So after the maturization of the maturization of the compost in the air bunkers, we are shifting it to the next process is the pasteurization, where we basically kill the pathogens and bacteria and viral infections, etc. So what are the cares we have to take when we are designing the pasteurization tunnel? The first point is RCC building designed to withstand high temperature, humidity and chemicals. So we have seen the temperature is going even 75 degrees centigrade, humidities are very high, there are a lot of chemicals are there like ammonia and etc. So we have to design the RCC entire wall and roof and floors to handle or to challenge or to withstand those conditions. Second is the RCC slab shall take load of the compost and moving loaders. This is again important point. Then pasteurization tunnel should have perforated flooring so that air can flow, steam can flow. Again I am repeating the same point that hole should be of proper size. There should be a right quantity of area available out of the total area for the movement of the air. We have seen that people are keeping maybe 20% of area open, 25% of area open, and then you will not have the right circulation of the air and steam. And if the steam is not getting rightly circulated, then the pasteurization will not be proper. And then if you take any gram out of that 25, you may find the pathogens, you will see the bacteria in it. So we have to consider that each and every gram of that 25 to 30 metric ton of the compost should be properly exposed to the steam, heat, and it is pasteurized. So building shall be insulated from all sides. This is very important because we are heating this with the steam, so there should not be loss of heat. The heat should get retained, then only the pasteurization will happen. Door shall be wide enough for the movement of loaders. Separate room and shade for air handling unit and boilers. Water drainage from the basement, lighting arrangement. So all these cares we have to take. So tunnel generally shall be sized for the compost material equivalent to the quantity in one bunker. So whatever the quantity you get in the air bunkers, the same quantity of the compost, for the same quantity of the compost, we have to design the tunnel. So this is how we have to have a planning in the process. Then next is the spawn mixing process, where we are basically mixing the spawn with the compost. We are mixing the spawn with the compost. So what are the cares we have to take? So spawn mixing area shall be designed for the sterile and clean conditions. The area should be enclosed from all sides and it should have the firm roof. The flooring shall be clean and even designed for the water cleaning. The room shall be provided with windows having fine mesh or filters to avoid entry of dust and pollens. Entry shall be provided for permitted and trained healthy laborers, because this spawn mixing area is like a intensive care area of the hospital. So after the pasteurization, we have to have the environment like intensive care units. So kind of a care hospitals take in operation of the intensive care unit. Similar kind of a care we have to take for the pasteurization tunnel, for the spawn mixing areas, for the growing areas or cropping areas, and for the packing and dispatch area. This is very important aspect. Then fifth is the entry should be provided only for the permitted and uh, trained healthy laborers. And sixth is the lighting arrangement, so that even in the daytime and night time people will have the right level of the light available, lux level of the light available, so that they can do their work very efficiently. Then growing rooms. So after the mixing of the compost with the spawn spores, we are shifting this into the growing rooms. So these are the points we have to address when you are designing the growing rooms. So these are the just a few points are there which we have given. So when we are going into actual design, there are many more considerations are there which we need to address. So we are not covering up all of those points because of the time available to make this video presentation here, but certainly we can address those points when we are designing this. So growing room shall be constructed using the steel structure puff PIR panel. Now again, important aspect I would like to highlight here, that people are not designing this steel structure or this growing room area or even rest of the infrastructure considering the earthquake and for the wind loads. So these are the some of the incidences happens once in the life of the project. Okay, so if for example winds are very gusty, there are turbulences, or you have the tornadoes like situations, then there is a possibility that your structure may fail, or your structures may fly like anything in that heavy wind, or it may collapse even. So we have to take care of those points. So we have to design those considering right level of wind load and even earthquake incidences. Then second is the foundation and floor should be designed to take heavy load of compost and shelf in each room. So we have seen that per shelf in the growing area you have around 12 metric ton to 15 metric ton, depending on the length and width of the shelf, of course, but you have very huge quantity of the compost. So so that all load of 50-60 metric ton is going to come on the flooring of the growing area. So it has to be very sturdy, it has to be very firm. Then third point is provide at least 2 feet foundation for the growing room buildings, so that you can even avoid the contamination, you can even avoid the mixing of the mud, dirt, or even coming the raining water into the growing area. The perk panel shall be provided with a proper support as per the designs prepared by the experts. Growing areas should be airtight and they should be thermally insulated. Flooring shall be firm and water resistant. Flooring shall have right slopes for water drainage, because you are spraying the waters for the cleaning and watering the beds, etc. Then sufficient lighting arrangements should be there. We have seen in the video, last video, that what level of lighting is required when you are operating in the growing area. So if sufficient lighting is not there, then it will affect even the picking rate of your people working in the growing area during the harvesting time. So they should get the light level, proper light level. So lighting should be proper so that the pickers can work comfortably. The doors of the growing room shall not open directly into open areas, so there has to be provided anti areas, anti rooms. There has to be provided corridors or the access areas, and all the doors should get open into those areas. They should not directly open into atmosphere or outside air. Doors shall open into corridors and passages to avoid entry of dust or even the infections. So you can see this picture. This picture itself will give the idea about the planning. So you can see this. So these are the corridors or the ante rooms, and these are the different doors. The floors are very clean. Then these are the controllers fitted outside each individual room, so from where you can continuously monitor the environmental conditions without going into the rooms. And even you can centrally monitor, as we discussed in the last video. You can have central monitoring station, you central observation center or central controlling station, and you can take all these controllers into that particular SCADA system through the PLC or microprocessor, etc. Even you can take this onto your mobile. Technology is available. We can take this directly on the internet. We can make the separate web page for showing the operating conditions, operating parameters. Even you can take the cameras inside your growing areas or in your farms onto the internet, and you can do the remote monitoring from your offices or during your traveling across the globe. So these are the technological, I would say, the benefits are available. We can implement that benefits. So we need to have the right planning, we need to have the right architectural designs in place, then we can get that level of finishing. So you can see that once you see this kind of a picture, you see that the owner is very much professional. The owner is very much careful about his the production. Owner is very much concerned about the quality of the products which he is growing. So that kind of confidence buyer always get when he sees these kind of pictures. So when you are marketing your product in the international exhibitions like Gulf Food exhibitions, and there are many more happening across the world, you can present the videos of your farm, you can present the pictures, you can make the catalogs, and you can insert the nice pictures of your farm, so that people will get the impression of the setup, and they will then be very much confident in giving the advance orders, regular orders onto your farm. So these are the basically the indirect benefits you get out of your right, wise, accurate and planned investment decisions. So doors are open in the common passage areas. You can see all these doors are opened. The passage shall be well illuminated, so there has to be a proper lighting in the passages. Room controllers installed for each room. So these are the things you can see how the cabling has done. You cannot see the loose cables. They are properly routed through the cable trays. You can see the quality of the cable trays, light, the infrastructure, the structure they have built. So many things you can see in this picture. So this is how, if you do it, certainly you get a lot of advantages. So going to the next point is the air handling unit, which is required for the growing area. So this is the room basically, and you can see this is the air handling unit where you are circulating the cold water and hot water, and this is basically a controller. Maybe you can have your own PLC controller or microcontroller, or we can have SCADA station also, like we discussed in the last video. If you are having 15-20 rooms or more than that, we can have centralized monitoring also. So, and those many sensors in the place. So if you have that kind of technology in place, certainly you will get a very good level of the production. And one point here, you will see that we are even circulating the hot water. In many of the plant in India, we have not seen the circulation of the hot water. People do not appreciate, or people do not understand, or the designers of these projects or the consultants of this project don't understand the value of providing a hot water into the age. But this is very important aspect of the project to get the right temperature, right humidity in the plant. So this is how you can keep the different air handling units. We can keep the air handling units either on the front side, or we can keep it on the back side, depending on the how you want to design your project, what kind of investment you need to make. So basis of that, we can take a call. So in this picture you can see these air handling units which are circulating the right quality of the air into the growing areas. So these are the return ducts, these are the supply ducts, and these are the pipes which are circulating the cold water and hot water, and these are the lighting areas. So you have the access bay, so you can even do the maintenance also around the clock. You can do the cleaning of the air handling units. Cleaning of the air handling unit is one of the very important aspect of the project. People miss on this. After every crop, the filters, cooling coils, these panels have to be cleaned, the ducts have to be cleaned, otherwise you will have the diseases of the last crop. So we have to make this entire area completely clean, sterile for every new crop. So if you are just cleaning the rooms, I would not say you are giving 100%. uh, so we need to clean it completely. So this is how you can do it. So if there is a proper access, if they are provided at a right locations, then only you can do these things. If you are providing at a certain inaccessible locations, then people will not reach there, or they will not get right access for the cleaning, or even your supervisors or even you yourselves cannot go and cross check whether they are really cleaned or not. So for the cooling coils, we requires the water of 4 to 5 degrees centigrade. Even we can take a call to increase this temperature and to save on the electrical power required to run the refrigeration machineries. And we require hot water also of 50 to 60 degrees. We can use the solar flat plate collectors. Even the top of the your growing areas, top of the all the roofs and structures you are building, we can use it for generating the electrical power through photovoltaic uh, power system, solar power system. So this is how you can go for the further uh, making your project independent of the outside source of energy. But these are of course the decisions basis of the return on investment required to implement those technologies. So you can see these pictures again, same thing we are repeating. Sometimes air handling units are hanged at a certain height, sometimes they are not accessible, sometimes they are installed on the ground. If you are providing at certain height, then there has to be a platform available so that people can go and see it. Even the HU has to be made out of the right quality of the material. So you can see this picture. So this entire HU has been constructed out of the stainless steel. All the parts of this air handling units should be accessible for the continuous observation, so that you can maintain these areas clean, free out of insects or germs, or sometimes the filters or the coils get clogged because of the dust, and then it impacts the air circulation even in the growing areas. So when you are designing the air handling units, we have to consider these aspects, like temperature should be available between the range 14 to 24 degree, humidity should be 85 to 95% should be possible, fresh air should be 25 to 30% of the return air, airflow requirement is 200 to 250 cfm per metric ton, but again we need to do a calculations for them. Then remember, India has a 3 seasons, and this is very important point. So summer you have 30 to 42 degree, humidity outside is 50 to 65. In the winter temperatures are going below even 15 degree nowadays, and rainy season again you have 25 to 35 degrees, even going 37-38 degree. So if you are operating the plant in the winter season, say at 15 degree or lesser, then that is not a good environment. Like the seasonal growers, they are generally facing those chilly temperatures in the winter season, and that is basically impacting their quality of the crop, their yield. But naturally their investment components are very less, they are very much prone to the nature, or they have understood the nature, or sometimes they are providing the some other methods of the heating arrangement in few farms in the northern India. So if you are having temperatures lower than 15 degree, we need to have the heating arrangement, and that is why we are always recommending hot water coils for maintaining the right temperatures. So these are the basically the specifications of the air handling unit. So cooling coils and the heating coils shall be designed for 2 to 3 degree of temperature approach with air outlet temperature. This is very important aspect, because if you maintain very big temperature approach, then your refrigeration machine will work for longer time. Then there is a possibility of the drying of the compost, drying of the casing, and then you will require frequent watering. And if you are going for a frequent watering, then it will create a problem for the caps of the mushroom. So we have to design these cooling coils and heating coils for right temperature approach. Of course your investment will be little bit more if you are going for small temperature differences between the water and the air outlet temperature. So this is what the point we are discussing here. So 23 degree is suppose the room temperature you are maintaining, then we need to reduce the temperature to 18 degree in the air handling unit, and this 18 degree air will go into the farm. It will pick up the heat of the compost, it will pick up the heat of the mycelium, because they are growing and there is a metabolic activity, and then the temperature will again come to the 23 degree. So we have to remove this heat, and we need to cool down the air from 23 degree to 18 degree centigrade. So we require the cooling coil, where the surface of the cooling coil is at 10 to 11 degree centigrade. So of course, to maintain 10 to 11 degree surface temperature, we need to circulate the water little bit lower temperature than this. So this is what the basically the concept of the cooling of air with the cooling coil. Now here there is a question, always people are asking these questions to us. Can we use the DX-AHUs like we have the split air conditioners in home, where you have the outside condensing unit and we have indoor evaporator unit or indoor unit like we have in our houses or homes? Or should we go for the chill water based air handling unit? So these are the questions. And nowadays There are many Indian companies without understanding the science of the uh, mushroom cultivation. They are recommending the people to utilize the DX kind of air handling units for their mushroom plants. And now even this technology is even now popularized by many of the Chinese companies, because this technology is very simple. It takes very less installation time. It is like you can forget the system after the plugging into the your PowerPoint. So these are the some of the benefits are there with the DX technology, but there are a lot of disadvantages. So your purpose of having the system will not get addressed, I would say, if you are going for the DX kind of a system. And if you go to the very good farms in the Denmark, Ukraine, Netherlands, and even in Canada, you will not see that people are using these technologies. So we need to understand few points here. The evaporation, which we are again discussing, because we have discussed these all points in very much detail in my last video number 3. So evaporation in the growing room has to be precisely controlled. Evaporation is a very important process, and which has lot of impact on the yield, which has a lot of impact on the whiteness of the white button mushrooms. And whiteness is very important aspect when you are going for the sell, or when you are asking for higher rates for your material. So evaporation in the growing room has to be precisely controlled. Compost and casing material should not get over dry, or you have to maintain the wetness of the flooring, or if it is getting continuously dried up, your compost, casing, wetness, your the flooring area, then you will require to continuously water them. And if you are continuously water them, then this water will deposits on the pins, caps of the button mushroom, and then you will have the bacterial diseases in your plant, and they will have the pitting surfaces. Sometimes they grow bigger than what you are expecting. They sometimes grow in bigger length of the stems, bigger sizes of the stems. Sometimes you will get odd shapes of the even mushrooms. So even you get sometimes offsets to the button mushroom. So these are the problems you have if you are not controlling the humidity, if you are not properly watering the plant, or if the evaporation is not proper, or if the air circulation is not the right. So cooling coil of the AHU shall be designed for low or mean temperature difference. So if you see this picture, so I am just taking the, for example, mean temperature difference, but when we are designing the cooling coil, we are considering actually the logarithmic mean temperature difference. But this is little bit complicated concept, or we consider the NTU concept, which is which the people who have the knowledge of the transfer will understand. We call them as a number of transfer units. So these are the concepts we are using when we are designing the cooling coil. So just for here explanation to the lay people or layman's, I would use this concept of mean temperature difference. So if you see this picture, 23 and 18 is the temperature range for the air. So if you take the average of this, if you find out the mean of this, your mean will come somewhere 20 degree, I would say. Okay, so 20 degree is suppose the mean, and the surface of the temperature is the 10 degree. Temperature of the coil surface is, for example, 10 degree, then you have the 10 degree of temperature difference. So if you have 10 degree of temperature difference, naturally the size of the cooling coil will be, for example, 10 square meter. So instead of 10 degree, if I design it, for example, for 5 degree of temperature, means what I will do, I will increase this surface temperature from 10 to 15 degree. So there is an advantage, because now you are not supplying water of 10 degree for the cooling, you are supplying 15 degree. And if you are designing it for 15 degree, then your difference will be 5 degree. So when if you have 5 degree of temperature difference, then what will happen? Your rate of condensation of the water from the air will be less. So this is advantage, and this is called, and this 10 degrees basically called the dew point temperature in the language of the psychrometry. Psychrometry is the science of basically air and water vapor mixture. So it is a different, I would say, the technology when we are designing the air conditioning systems. So those people who have the background in HVAC and refrigeration, they will understand these concepts. So for a lay person, you need to understand that the difference between the air and the coil surface has to be as small as possible. So generally here we do the trade-off, because if you go for a smaller temperature difference, the size of the coil is increasing, then the cost of the coil is increasing. So we have to do the right balance between the amount of investment you need to make the cooling coil and the temperature difference. So in market we have seen the people are even going for very high degree of differences. So naturally their cost of the cooling coil will be very less. They will be very cheap as compared with the other people who are offering the bigger size coils. So bigger size coil is basically recommended, because then you will have a lesser rate of condensation of water from the air. So that is what the important point I would like to address, or I would like to explain to you people. So lower the coil surface temperature mean lower is the dew point temperature of the coil surface. So if you operate your coil with 5 degree of water instead of 10 degree, means you are operating the coil at a lower dew point temperature. Now in the last example we recommended to operate the coil at 15 degree, means you are operating coil at a higher temperature, means your dew point temperature has also increased, means your rate of water condensation will be very less. So mean more rate of condensation of water from the air. So DX type of air conditioner technology always operates at very low coil surface temperature. Now in the chill water case, what is happening? You are supplying the constant rate of chill water. You are generating the chill water in your water cooled chiller at 7 degree or at 8 degree or at 10 degree, but which will be remain constant because you have set the water chiller for that temperature. So you are maintaining that temperature. But when you are using the DX type technology, then refrigerant temperature in the coil is not constant. When you are starting the machine, for that particular period of time, your evaporation pressure will go down, and naturally with that your suction pressure will also go down. Sometimes your refrigerant charge is very low in your system. If it is not properly balanced, then again your coil will work at a reduced suction pressure. Or there are other uh, points are there, that is your proper balancing of your thermostatic expansion wall, or suppose you are using the electronic expansion wall, then operation of the compressor, whether you are using the VFD system for the compressor, etc. So basis of that the evaporation temperature will be decided. So of course if you are supplying the chill water, you will have the uniform coil surface temperature, but if you are using the DX type technology, then it will be varying. So if you are using DX type, then I will give the example like this. So your temperature will be varying between 5 to 10 degree. So continuously your temperature is varying between 5 and 10 degree. So if your temperature is going down to 5 degree, that time what will happen? The air which is flowing over the coil will get dried, because the condensation of water will be more from the air. So that is the reason the very good farms or modern farms, or the people who have the understanding of the science of cultivation of the mushroom, they are not recommending DX type AHUs, though DX type AHUs looks very attractive in terms of the investment, because your investment is very low. The way or the time required to install the DX type AHU is very low. You do not require to have a separate chill water system like water chiller or the cooling tower, etc. So it looks very attractive. That is the point I wanted to make. But again, if you go for evaporative condenser kind of system with ammonia kind of a refrigerant, or maybe some other low GWP refrigerant which are now available in the markets, you can have even better power consumption than the DX type AHUs. And another point I would like to address here, that in most of the DX type AHUs, the condensers are air cooled condensers. So generally they are consuming a lot of power. So for example, if you are having chill water based systems, then chill water system will consume around 0.8 kilowatt per 1 ton of refrigeration. So if you are having, suppose for example, 1 ton of refrigeration load, it will consume 0.8 kilowatt of electricity. Means for every 1 hour you will have 0.8 kilowatt hour of power consumption. 0.8 kilowatt means you will have 0.8 units of power. But if you are going for air cooled unit, then the power consumption will be 1.2 to 1.25 or 1.3. So you will end up in paying 0.4, 0.3 to 0.4 kilowatt more if you are going for DX type AHUs. And if you are going for suppose 200 TR system in your plant, then you can calculate. So 200 into this 0.3. So almost you will spend 60 kilowatt more. 60 kilowatt means you can convert 60 into 8 rupees is the cost of electricity for 1 unit. So 60 into 8, so around 480 to 500 rupees you will be paying extra because you are having the DX type system in your plant. So this is how you have to do the calculations. You need to study the economics of any technology, and apart from that there are disadvantages, like you are having higher rate of your operations, your casing temperatures are not getting properly maintained, humidity of the air is not getting rightly maintained, so many other disadvantages are there. So that is the reason the experts in the field, we have understanding of science of growing mushroom and science of air handling unit operation, they will not recommend the DX type technology for the mushroom plant. So coming back, so you can see these pictures, how nice your plant look like. So you have the air handling unit, we have the controllers, doors, floors, there are proper gutters are there in the floors, how clean it is looking. So this is a very big plant. This is having around 15 plus 15, around 30 rooms. So this project is of 30 rooms of plant, and you can see how clean it is looking, and no outside air is coming into the corridor area. So this is how you are maintaining the right environment, you are maintaining the clean environment in the project. So if you visit any of the plant, you will not see that level of cleanliness, you will not see that level of designing has been addressed in the plant. So flooring should be smooth and clean, there should be proper light level so that you can see the how the people are moving effortlessly with their trolleys. So this is how, if you can design the plant, then naturally you will get the better export orders. So export orders are basically depending on your certification and the standard operating procedures, the cleanliness practices, and the reliable quality, uniform quality of the material or the produce which you are cultivating in your farm. So you can see these pictures. So the material is rightly placed, rightly stacked, the material is properly removed using the trolleys, so efforts required are very less. So all these things you can address if you have the right planning. So the knives which are required for harvesting to remove the buttons from the stems, they are properly secured, they are properly tagged, and then you can have the proper washing of them, proper sterilization of them, because you are handling the food and sterilization is very important aspect. And now people are even the consumers are now getting more attention, they are getting now more educated with the quality of the mushrooms they want to consume. So we need to provide the aprons, gloves and caps, so they should be sterilized, they should not be unclean, full of dirt, full of mud. So whosoever your people, they should feel proud if they are having again the uniforms, aprons, they will also feel very proud. And we have to provide very right level of, you know, environment, professional environment, so that that attitude will come into the people. So we have to nurture those values system in our project, which is very important aspect. So picking, cleaning and sorting at one time, you can see this. So we have seen in India people are just picking, they are not doing the sorting and cleaning. So that lady you can see here, so she has different trays. So when she is picking up material, at the same time she is stacking these properly, so you reduce the time overall in handling. If you are handling the same material again and again, then it will get contaminated, even it will get more, and it will become more dirt, it will attract more dirt. So we have to take all those cares, and you can see the whiteness of the mushrooms. You can see this, you will not see any dirt, because they are growing on the surface of the casing. In India we have seen they are growing either in the casing or below the casing sometime, and they are full of dirt, and they are full of brown and black spots. So if you are growing this quality of material, certainly you will get very good rate in the market. You will feel very proud when you are selling this material, when you are taking this material in the market. So this is the high-tech way the people do the picking. You can use even automatic system also, but this is not recommended to go for this level of high-tech picking. We can use even simple methods, and you can build up that level of efficiency in the farm. So you can see the level of flush in the plant, the level of lighting, so many things you can see in this picture. These are the shelves. Generally aluminum is recommended because it is a rust free material, but it is very costly. So you can use the hot dip galvanized steel, but again the material should be scientifically hot dip galvanized. It should not be painted. People are using the galvanized paint, that is not the way. It should be hot dip galvanized for a proper thickness. So there is a particular standard is there, so you have to use that particular way method for checking the quality of hot dip galvanized. You have to see their thickness of galvanization. There are some meters are available, so through that meter we can check the level of galvanizing on the steel surfaces. Otherwise all galvanized materials are not same or of not same quality. Okay, so this we have to address. Then packing area. So packing area environment should be maintained between 7 to 8 degrees centigrade. We know that button mushrooms are highly perishable. Washed in solution 5 gram potassium metasulfide in 10 liters of water for removing the soil particles, as well as to improve the whiteness. Packed in perforated poly bags and stored at temperature 3 to 4 degrees centigrade. Plastic is not the right choice for packing of button mushrooms. Plastic is not the right choice for packing of button mushrooms. So these are the packing boxes. So these are available for 1 rupees. If you are going for mass purchasing, even you can get at better rate than this. And this is the material we are recommending for the packing. So even packing material also defines the life of the material of the mushroom. If you are using the plastic, then it will last for 4 to 5 days of a time. But if you are going for the different materials, they will last for even 8 to 10 days of the time. So far we have discussed very important design considerations. Now this is going to be last video. We will again meet in the last video number 5, where we will see the economical aspects. We will see how to make the project report, what is the total investment required, what are the documents required, and so many things which are not related to the science of cultivation, but which are related to the financial aspects. So far we have discussed in very much details in last four videos about the market, health benefits, different products which you can make, then how to do the planning of the entire processes. So many things we have discussed in detail. I hope that you have appreciate the all the last four videos, and if you have certain queries, questions, if you want more clarification, or if you have more suggestions so that we can improve upon our presentations in the future, please call this number, please WhatsApp on this number, or please post your comments very honestly, transparently in the comment box. Thank you very much. See you back in the video number 5 with economical aspect, with financial aspect of this project. Thank you very much.